All right, guys, this is Mr. Allen, and I'm going to do all the examples for section 4.5, which is on the substitution method. Here we go. So here's example 1. So I'm asked to integrate this expression, and it looks pretty. Now, one thing I could do is I could expand that, couldn't I? I could take the x squared plus 1 and times that by x squared plus 1, and then take that times 2x and then integrate, right? I'm not going to do that. What I'm going to do is I'm going to notice what's the derivative of x squared plus 1? It's 2x. That's very important to note. This and this are kind of like the derivative of that. So what I'm going to do is I'm going to say u is x squared plus 1, and therefore du, the derivative of u, would be equal to, well, what's the derivative of x squared plus 1? 2x. Now I'm going to add something here to the end. I'm going to write dx. Just like over here, the derivative of u is technically 1, right? But we're talking about the chain rule, right? So the derivative of u is 1 times du, if you will. The derivative of something in terms of x is whatever it is, and then dx. Make sure you add this little piece on there, okay? Now what I'm going to do is I'm going to use substitution with this integral. And guess what I'm going to put in for x squared plus 1? U. And by the way, it's squared, isn't it? In fact, yeah, I'll just leave that like that. And what's 2x dx? Well, 2x dx is, now, so here's what I'd like you to observe. Doesn't my integral in the green look much easier, I think, than the original integral, doesn't it? So let's go ahead and integrate that using the power rule. What's the antiderivative of u squared? U cubed over 3 plus c. Oh, and last but not least, what was u? X squared plus 1. So the final answer is x squared plus 1 to the third over 3 plus c. Okay, so here comes example 2. So the first thing we want to try to do is figure out what our u should be. So in this case here, I mean, there's really kind of only one thing to let it be. And I mean, it's just 2x minus 1. I mean, there's really not much else it could be, right? And by the way, if that's u, I then want to do the derivative of both sides. So the derivative of u is du, right? What's the derivative of 2x minus 2 or 2x minus 1 though? Well, it'd be 2. And then don't forget to add that little dx part. Okay? And I'm just forewarning you on a quiz or a test, I need to see that dx. Now we have another little issue with this problem. This is the u, but look what we don't see up here. We don't see that extra 2 there. Do we have a dx? But we don't have a 2 dx, do we? That's okay, we can fix it. Guess how I could get rid of that 2? If I wanted to change 2 to just 1 dx, what would I do? I would divide by 2. So this is 1/2 du equals dx. Now I know what I'm going to put in for dx. Well, I'm going to put in 1/2 du. And what am I going to put in for 2x minus 1? U. In other words, this integral is going to change into 1/2 du. By the way, that was the dx part, right? And then I got to do u to the, now if you guys don't mind, I'm going to go ahead and show extra work here. It's just 1/2 u. Or I'm sorry, the square root of u, which is going to be an exponent of 1/2. We'll get that in the next step. Hopefully you guys are familiar enough. We've done enough of these integrals. Now I'm going to use my power rule, right? What do I do with that exponent of 1/2? You add 1, which would make it 3 over 2, and then you have to divide by that 3 over 2, right? So then that's going to be 1/2 times u to the 3/2 over 3/2, and then don't forget the constant integration constant c. So then that's going to be 1/2 times 2/3, and then that's going to be u to the 3/2 plus c. The 2's are going to cancel, right? So then this is going to be 1/3, and then instead of u here, let's just go ahead and put what u is. 2x minus 1 to the 3/2 plus c. That's your answer. I'm going to go ahead and pause. All right, here's example 3. Guys, what do you think u should be? Okay, so, and the reason you want to pick that is because you know the derivative of that is 3. Now, but instead of just writing du equals 3, we're going to write 3 dx. So please make sure you throw the dx on there. Now we can convert this as the following. This will be the integral of, well, first of all, what are we going to put in for 3x minus 1? U, which is to the 4th power. Ooh, that looks bad, but hopefully that looks like a 4 and a u. Oh, and then what are we going to put in for dx and the 3? Oh, 3 dx is du. So what I've done is I've converted this complicated looking integral into something I think that's a lot more manageable. So I'm going to use my power rule. So I'm going to add 1 to the 4, which makes it u to the 5th over, and then 5. That's our power rule, plus c. Last thing, change the u back to 3x minus 1. So it's 3x minus 1 raised to the 5th over 5 plus c. Now I'd like to make a comment here. You might think, Mr. Allen, if I wanted to, could I go ahead and take this out to the 4th power and then differentiate it? And then integrate it that way? Can you do that? Absolutely. Would it be a lot of work though? Trust me when I tell you it's a lot more work than this. And plus, on the quiz, instead of giving you, to the 4th, I might give you to the 40th power. That would not be fun, would it? Okay, good. So here's example 5. Now we have to make an important decision. Do we let this be u or do we let the second thing be u? Second thing. Why the second thing?
The first thing is d.
That's right. The derivative of e to the x plus x is literally e to the x plus 1. So I'm going to let u equal e to the x plus x. Therefore, du would be equal to e to the x plus 1. The derivative of e to the x is e to the x. The derivative of x is 1. And again, don't forget to add the dx there. In other words, this integral is actually, you could think of it as, well, what are we going to put in for this? U. What are we going to put in for this? Du. It's ridiculously easy now. Look at this integral compared to the first one would almost make you want to cry when you first look at it, doesn't it? Okay, what is the integral of u? U squared over 2. Don't forget the plus c. And now finally convert it back. So that's going to be e to the x plus x squared over 2 plus c. That's your answer. Have a nice day. Crazy. Not really difficult once you get the grasp of it. But this is what we call u substitution. I'm going to break there. Here's example 3. What would you let u be? U is x cubed plus 7. What's du? It'd be 2x dx, right? The derivative of, 3x squared. Sorry, not 2x. Sorry. That was bad. But we have a problem here, don't we? There's no 3 up there. So what are you going to do? Yeah, divide both sides by 3. So you'd have 1/3 du is equal to x squared dx. That's going to go in for this. And then we're going to put this in for u. In other words, this integral is going to change to 1/3 du. That's what I'm putting in for the x squared dx. Integral of u to the 1/2. Hopefully you guys remember we did an example earlier with an exponent of 1/2 from the square root. Same idea. Now we're going to use our power rule. So if I add 1 to 1/2, I get 3/2. But then I have to multiply by 2/3, and then plus c. So the fraction you get in the front there is going to be 2/9. So the final answer here is 2/9, and then x cubed plus 7 to the 3/2 plus c. I don't know if any of you were able to get that one in your head. You got to be a little bit careful because you got some fractions floating around there, which again tends to make things a little bit more difficult for students. Questions on this one? What are you going to let u be on this one?
Cosine squared.
Not cosine squared. Close. Not sine. Cosine. So guys, this is one of the things where you've got to really play around with these problems if you're going to really try to understand them. And the only way you're going to get good at it is by practicing. You want to let u here be cosine x because the derivative is negative sine x, right? dx. Oh, okay, so, oh wait, there's no negative. What am I going to do? Yeah, just bump it over to the other side, right? Or divide by -1, however you want to say it. So can you see, what am I going to put in for sine dx? Well, negative du. What am I going to put in for, and I'll do it in yellow here, what am I going to put in for this cosine x? U. In other words, this whole thing is going to become negative integral u squared du. Now look at my black integral. Doesn't that one look much easier to deal with than the integral of cosine squared x sine x dx? Okay, power rule. What's the exponent going to become? 3. So it's going to be negative u to the 3rd over 3 plus c. So final answer is negative cosine to the 3rd x over 3 plus c. I know that I'm making that look really simple. It takes some practice. You might be unsure of yourself, and you might initially guess. Okay, we're skipping example 4. I'm going to go right to example 5, even though it says student practice. And the reason I'm doing this one is it's actually a little bit easier than example 4. And I kind of want to go, how is this problem different than all the other problems we've done thus far? It's a definite integral. So here we can see that we're not just integrating some expression, we're definitely integrating. In other words, we're going to actually get a numeric answer here. And I'm going to kind of combine what we've done, and I'm going to add one little twist to this one. So first of all, can you guess what u is going to be in this problem? How many of you are thinking, I think it's going to be x squared minus 1? That's what you're going to do because the derivative of something squared is going to be just x. Now, technically, it'd be what? It'd be 2x dx, right? Crud. There's a 4x up there, though. How am I going to deal with that? I would just multiply both sides by 2. Now, guys, what I'm trying to do here is give you enough variety that you guys are kind of okay if they throw it. There's one curveball I haven't given you, and I won't give it to you today. We'll talk about it tomorrow. But I'm trying to give you just enough to where it'll make you dangerous, and you'll be able to attack most problems, no problem. I think that was a contradiction. Anyways. Now, here's the other thing I'm going to do. You see this 1 right here? I claim that it's going to change to 0. And here's why. We're going to change this integral into everything in terms of u, correct? U is defined as x squared minus 1. This 1 is in terms of x, isn't it? So if I want to write it in terms of u, I've got to use this rule. So what is 1 squared minus 1? 0. By the way, what's the 2 going to change to? If I plug 2 into this, what do I get? 3. So 2 is going to change to 3, which is kind of odd. But here's what we then can say. This integral is equal to 2 integral from 0 to 3 of u du. I'm just going to write it down, and then I'm going to try to make sure I connect all the dots. What are we putting in for the 4x dx? 2 du. So that's where the 2 is and the du. And by the way, I hope you guys understand why the 2's in the front. We don't need to leave it in the integral. Where did I do with this x squared minus 1? Well, that's the u, isn't it? Or if you wanted to, you could even say it's u to the first. 1 changed to 0, and 2 changed. By the way, does this integral here look way easier than that integral? By the way, we're going to check with our calculator just to make you hopefully feel good about our answer. What is the antiderivative of u? It'd be u squared over 2, and then we need to evaluate that from 0 to 3, right? Oh, what happens to those 2's? It cancels. That's nice. U squared, we just need to evaluate from 0 to 3, so the answer is 9. Would you do me a favor? Take a moment now with your calculator. Just literally plug this in your calculator and hit enter. Let the calculator do the calculus for you.